Oh, hey guys. We're gonna do a little bit different. I'm gonna use a different program because I think the other visualizer or the other document camera program that I use is a little bit jerky, and I think this is a bit smoother. Get to see my face, but I don't know. You guys know what I look like by this point. Um, yeah, so we're just gonna keep on trucking. This is 8.6, solving problems involving the area of a circle. So this girl Latoya cut a circle into 8 equal sections, kind of looks like a pizza, and arranged the pieces to form a shape resembling a parallelogram. What a weird thing to do with a pizza. Why is one half yellow and one half green? Sure, maybe it's not a pizza. I don't know. So how is the base length of the new shape related to the circumference of the circle? So the base length of the new shape is like this, right? This 1/2 c. Now it's 1/2 c because it's basically half the circumference of the circle, right? This all the way around the circumference would be that 2 pi r. Um, uh, so if we take half of that circumference, basically half of that 2 pi r, that's basically half. That's basically just pi r, right? So we would say this base length here, 1/2 c, 1/2 of the circumference is equal to pi r, right? So another way to put that is that half of the circumference, and again, the circumference is just the distance around the circle if you were to walk it. Circumference um, is equal to the base length of the parallelogram. Right, and again, that's that base length of the parallelogram right there. Okay. How's the height of the new shape? Equal or shape related to the radius of the circle? Well, the height of the parallelogram is always that vertical distance right there. Oh, hey, you're good. No, you're good. You can do it. The height is equal to this right here. They've already got it kind of labeled as the radius, right? But it's also the height, right? So the height is the same thing as the radius, is the same value, let's say. All right, the next part of it is some good old fashioned derivation of a formula. We're talking about the area formula of a circle versus the area formula for a parallelogram. So the area formula for a parallelogram is the area equals the base times the height. Basically, that base length times the height right there. Really similar to a rectangle. Yeah, same exact formula. And the area formula for a circle is, well, we'll get there actually because we're actually deriving it. So the idea here is that we know that base height is the same thing as the 1/2 c. Okay, we kind of already looked at that, right? So we can put that in here, 1/2 c, and we know the height is equal to the radius, so we can multiply it by that radius. Okay, this is the same thing. That b, that base height or that base length, is at 1/2 c, and that height is the same as the radius. Okay, and then um, we know the formula for circumference is 2 pi r. So we can take that 2 pi r right here and substitute it in for that value for c right there. So this becomes a equals 1/2 times 2 pi r times r. Okay. Now 1/2 times 2 is just the same thing as 1, so we can get rid of that. So the area formula for a circle is pi times r times r. Now we can simplify this r times r to be r squared. So that is the area for a circle. That's how you figure it out, is that formula right there. And we're going to be using that extensively in this video. I'm going to go close my door. I'll be right back. Okay. The floor, that's probably the floor for a new butterfly conservatory. I'll fix these on the actual one you guys use. The floor for a new butterfly conservatory will be a circle with an 18-foot radius. It's got it right there. The material for the floor will cost $3.95 per square foot. About how much will the floor cost? It's a good real-world problem involving area of a circle. So the idea is we use that area for a circle. Formula is a equals pi r squared. We just figured that out. Right? The radius is 18 feet. So that's where we get that value right there. And then we plug that into the formula, right? So we take that 18, plug it in right there. So it becomes a equals pi times r squared. So it's going to be 18 squared, and we're going to multiply it. That's why I'm doing the parentheses. I could also do the dot. It's the same thing. 18 squared is going to give us, I believe, 324, but let's double check. 18 squared is 324. So A equals 324 pi. Now we can kind of go in two different ways. There's going to be one question on the test where it leaves it in terms of pi. So we'll do that first, and then we'll convert pi to a decimal, would be 3.14. But we'll leave it in terms of pi first. So we're going to take this 324 pi, and let's actually write it out because it's square feet. So we need to write the units, right? So we can actually take that and then multiply it by the price per square foot, which is that 395. Okay, so we can take that 324 pi and we'll multiply it by 395. So we'll take that 395 and just multiply it with the 324. We'll leave pi as it is. You can kind of think of it in terms like it's a variable, right? You can manipulate it the same way. So we've got that 324 times 395. So this gives you 12. Let's round that up to 1280. Okay. So you would say the area would be 1,280 pi feet squared. So that's one way to think about it, right? We can leave it in terms of pi. The other way to do it is to take this pi and convert it to 3.14. Okay, so now if we do that, then we get to this 1280 and we would multiply it by 3.14. Okay, so then we just use the old calculator here. We get that 1280 times 3.14. We get to 4,019. And this isn't the, oh, right, this is the area. Oh, no, I already did this. This is a cost. Because we put it in terms of cost over here. So the cost of the flooring will be that $4,019 and 20 cents. So yeah, that would be kind of your answer right there. Okay. This is the same thing though. We've already kind of like put the cost into it to figure it out. But yeah, kind of two ways to write the same thing. That 1280 pi is the same thing as that 4,019.20. Maybe a little bit more useful to do it like this because it's a word problem. But I don't want you to get to the test and that be the first time you've ever seen a problem put in terms of pi before. Okay. At a school play, there's a spotlight above the center of the floor that covers a lighted area with a radius of 7 feet. Oh, there we go. What is the area covered by the spotlight? Man, these are so easy, guys. We've got the formula. We've got the radius. We take that 7 and we plug it in for the r. So it becomes a equals pi. Let's do that. Pi times 7 squared. We know 7 squared is 7 times 7. So that becomes 49 pi feet squared, right? And we also know that we can take that pi of 3.14 and take that. Let me write that because I don't want that extra decimal in there. So a equals 49 times 3.14. And then that will get us to this in terms of a decimal rather than in terms of pi right there. Again, it's the same thing, guys, just a different way to represent it. So we take that 49 times 3.14. We get to 153.86. We'll round that up to 154. So the area of the spotlight is 154, what did I say, feet squared? Yeah. Feet squared. Yeah, there you go. The athletic department wants to paint the school's mascot logo on the gym locker room wall. They start by painting a solid blue circle. What is the maximum diameter of the logo if only 1 quart of the blue paint is used? So they tell us that that's the biggest area that it can cover, right? So we've got the area as 78.5 right here, okay? And remember, the formula is that pi r squared. So the idea is rather than giving us the radius first, like they did in this problem, And this problem, they're giving us the area first. So we're going to take that 78.5 and plug it in for that A right there. Focus this a little bit. So when we set up our problem, it's going to be 78.5 is equal to pi r squared. Now, we're not going to leave this in terms of pi because it's weird when you divide it. So we're just going to convert that to 3.14 right away. So this is going to become r squared, right? R squared's left. I'm just going to flip it over to the left side because I, like all math teachers, like my variables on the left side. Now we're going to take that 78.5 and divide by pi. Oops, 78.5 divided by 3.14. Oh, look how easy. Oh my gosh. It works out so well. Now, what number multiplied by itself gets you to 25, right? The kind of formal way to do this is to square root on both sides, right? If I square root the exponent, that makes it go away to get to a radius of, and then we'll take the square root of 25 is 5. Look at that. So the radius is 5 feet. But it's not looking for the radius, it's asking for the maximum diameter of the logo, right? Hopefully you know that the way to find diameter from radius is to multiply it by 2. So diameter equals 10. So the maximum diameter of the logo is 10 feet. Okay. Similarly to this one, it does not start by giving us the radius. What this does is start by giving us the circumference, right? So you've got the circumference is 176 feet, and we know the formula for circumference is C equals 2 pi r, which right there. Okay. So this is basically the distance around the pen, the chicken pen, hen pen. I don't know. And so rather than working with the radius, we're working at the circumference. So we're going to plug that in for right there. It's going to be 176 equals 2 pi r. So we're going to divide by 2 pi. Okay. And we're just going to do this whole thing in the calculator, right? So that's going to get us 176 divided by 2 times 3.14. Okay. If you multiply that out, it's 6.28. So the same thing as 176 divided by 6.28. We're going to leave this as 28. We're going to round it down. So the radius is 28 feet. Is that right? Yeah. Okay. But we're looking for the area, right? So the area, remember, is pi r squared. So we take that 28 and plug it in for that r. So it becomes a equals pi times 28 squared. So then we'll just kind of like do all this in the calculator, right? 28 squared. 28 squared is the same thing as 28 times 28 is 784. So we get to a equals 784 pi feet squared. So that's in terms of pi, but if we want to convert it to a decimal, we know that pi is 3.14. So this becomes 784 times 3.14, which again, we're just going to throw this in the calculator. 784 times 3.14 gets us to 2461.76. So A equals 2,461.76 feet squared. Yep. So the area of the pen is 2,461.76 feet squared. Oh, man. Sorry about that, guys. I really kind of like ended that little box too early. There you go.